Have you ever wondered where all the elements in the universe came from? This question, seemingly simple, has puzzled scientists and philosophers alike for centuries. The answer lies in a fascinating process known as nucleosynthesis. Nucleosynthesis is the cosmic process of creating new atomic nuclei from pre-existing nucleons, the particles that make up an atomic nucleus. It's the very heart of how the universe forges elements. Think about the world around us. The oxygen we breathe, the iron in our blood, the calcium in our bones, and even the gold in our jewelry. All these elements were not just lying around after the Big Bang, they were created. And not just anywhere, but in the intense, unfathomable heat and pressure at the heart of stars. You see, stars are not just beautiful twinkling dots in the night sky. They are cosmic factories churning out the building blocks of the universe. When a star forms, it's primarily made of hydrogen and helium, the two simplest and most abundant elements in the universe. But as the star ages, it begins to cook up heavier elements in its core, from carbon to oxygen, silicon, and even iron. This stellar alchemy doesn't stop there. When a massive star explodes in a supernova, the incredible energy released allows for the creation of even heavier elements like gold, platinum, and uranium. So every time you gaze at the stars, remember this. You're not just looking at distant suns, you're looking at the birthplaces of elements. The elements that make up our world and us were forged in these cosmic crucibles billions of years ago. Thus, the elements we see around us, and even those that make up our bodies, are not just cosmic dust from the Big Bang. They were formed in the heart of stars. The process through which these elements are created is known as nucleosynthesis. So, what exactly is nucleosynthesis? Well, let's break it down. Nucleosynthesis, in the simplest terms, is the process that creates new atomic nuclei from pre-existing protons and neutrons. It's kind of like a cosmic bakery where the universe cooks up every element on the periodic table. But where does this happen? The answer lies in the heart of stars. Yes, stars are not just pretty twinkling lights adorning our night sky, but they're also cosmic ovens where the magic of nucleosynthesis takes place. Let's imagine a star, much like our sun. In its core, under extreme pressure and temperature, atoms of lighter elements like hydrogen and helium are squeezed together in a process known as fusion. This fusion of lighter elements produces heavier elements such as carbon, oxygen, and all the way up to iron. But you may wonder, what about the elements heavier than iron? This is where supernovae come into the picture. When a star exhausts its nuclear fuel, it collapses under its own gravity and explodes in a supernova, a cosmic event of extraordinary magnitude. In the furnace of a supernova, temperatures and pressures are so high that elements heavier than iron, like gold, uranium, and plutonium, are created. Now here's a fun fact. Every atom in your body, the air you breathe, the screen you're looking at, the ground you're standing on, was once cooked up in the belly of a star. Nucleosynthesis is the cosmic recipe that has baked the universe as we know it. So in a nutshell, nucleosynthesis is a process of element formation that takes place in the cores of stars and during supernovae. It's the universe's way of recycling, taking lighter elements, and under immense pressure and temperature, turning them into heavier elements. It's not as complex as it sounds, is it? After all, we're all just stardust cooked up in the cosmic kitchen of nucleosynthesis. Now, let's delve deeper into the steps involved in nucleosynthesis. It's a process that has been going on for billions of years, right in the heart of stars, creating the elements that make up our universe. Let's first talk about hydrogen burning. Picture a star like our sun, blazing in the vast expanse of space. Deep in its core, something amazing is happening. Hydrogen atoms, the lightest and most abundant element in the universe, are coming together under immense pressure and temperature. They're not just huddling for warmth, though. They are actually fusing together to form a new, heavier element, helium. This fusion process is what we call hydrogen burning, and it's the first step of nucleosynthesis. But the process doesn't stop there. You see, helium, the product of hydrogen burning, is not content just being helium. It wants to be something more, something heavier. And so, under the right conditions, helium atoms begin to fuse together. This fusion of helium atoms gives birth to even heavier elements like carbon and oxygen. This process is known as helium burning. Helium burning, however, is a bit more complex than hydrogen burning. It involves a series of reactions, collectively known as the triple alpha process. In this process, 3 helium nuclei, or alpha particles, come together to form a carbon nucleus. This is followed by the fusion of another helium nucleus with the newly formed carbon nucleus, resulting in an oxygen nucleus. So you see, through these steps of nucleosynthesis, we go from hydrogen, the lightest element, to helium, and then to carbon and oxygen, elements essential for life as we know it. Each step involves a fusion reaction where lighter elements combine to form heavier ones, all under the intense conditions within a star's core. And just like that, through a series of fusion reactions, heavier elements are created. To sum up, nucleosynthesis is a fascinating process, isn't it? It's the cosmic recipe for creating all the elements we know and love. From the oxygen we breathe, to the carbon in our bodies, to the silicon in the sand beneath our feet, all are products of this intricate process. Nucleosynthesis is a grand term, but it simply refers to the formation of nuclei. It's the process through which all elements in the universe are formed. It's a stellar kitchen where atoms are cooked into elements. And this is not just any cooking, it's an intense, high-pressure, high-temperature process that happens at the heart of stars. The process of nucleosynthesis involves a series of fusion reactions. It starts with the fusion of hydrogen atoms to form helium. This is the first step, a process that releases a vast amount of energy. This energy is what makes stars shine, and it's what keeps them from collapsing under their own gravity. But the process doesn't stop here. As stars age, they start fusing heavier elements. Helium atoms combine to form carbon, then carbon fuses with more helium to form oxygen, and so on, up the periodic table, with each step requiring higher temperatures and pressures. What's truly remarkable is the fine balance that exists in this process. The conditions inside stars need to be just right for these fusion reactions to happen. Too hot, and the atoms move too fast to stick together. Too cold, and they don't have enough energy to overcome their natural repulsion. And let's not forget, this process is not only responsible for creating the elements, but it's also the driving force behind the life cycle of stars. From their birth in stellar nurseries to their death in spectacular supernova explosions, nucleosynthesis plays a key role. So next time you look at the stars, remember, you're looking at cosmic factories where all the elements are made. In conclusion, nucleosynthesis plays a crucial role in the formation of elements. This stellar process is the cosmic forge where the universe's elements are crafted. It starts with the simplest element, hydrogen, and through a series of nuclear reactions, heavier elements like helium, carbon, oxygen, and all the way up to iron are created. This process doesn't stop at iron, though. When a star explodes in a supernova, the extreme conditions allow for the creation of elements heavier than iron. Gold, platinum, uranium, and all the elements you see in the periodic table owe their existence to this extraordinary process. So in essence, nucleosynthesis is the grand architect of all matter in the universe, taking raw materials and forging them into the building blocks of everything we know. Isn't it amazing to think that every atom in your body was once part of a star?